Good morning. Oops, looks like it's way too dark. Let's see if that fixed it. Nope. All right, a little bit better. Good morning. So today I'm going to be working on a little bit of developing a reader for BGEO files, well, really simple BGEO files inside Blender, and then using that inside Blender itself in order to do some visualizations of orbits. So here's what we're going to do. Let me go ahead and I'm going to start out here. This is my empty Blender scene file. And actually, you know what? Let me turn on some music for myself. You know what? There's a new Garbage album out. I'm going to give that a listen. All right, so let's take a look. Here we've got Blender. And then over here, what I've got is my .ksy file. So the way that I've been setting this up, I mostly mocked up a real simple set of readers inside KaiTai struct for this, where we've got this magic value that starts at the beginning. This is a very small restricted subset of the types of data that that BGEO supports. I am going to load now NoBH orbit 0 with this. We can take a look at it. Okay. So a couple things of note here. Oh, it's too small. Let me zoom in. And actually, for now, let me put this in the upper right. So the way that I've got it set up right now, because I was trying to understand it myself, it's not well suited to KaiTai struct because it's a set of individual records, and that's why you see it taking so long to load up. The individual records here are the attributes. There's metadata at the beginning about each one of these, attribute size, attribute type. There's also like a default value that it includes. There's attribute types float. Almost all of these, or I think in this particular case, they're all floats. And then the way that it stores these, and there's no primitives here, so this is empty. But the way that it stores these is it stores each individual particle as a record. That record starts out with a position, and then it has a set, and the third value of that position is always, I think it's always 1, but I'm not 100% sure on that. Let's take a look. Yeah, it looks like. There may be some other piece of information there that's being stored. Maybe that's the W or depth value or something. I don't know. And then each one of the attributes I've set up as an instance, or I've set up instances for it that are the name of the different things. So this is actually really quite slow, and it's not how we ultimately want to be able to access the data. So what we actually want to be able to do is we want to be able to access this as an array. So what I'm going to do is first we're going to go in here, and actually I'm going to go into my standard directory. I'm going to open up VS Code, and we are going to write our own little parser for this. So we will do a new file. It takes a second to initialize VS Code. And we're going to set this up to import. Look at all that. We're going to import NumPy. And we are going to, I don't want that. What we'll do is we'll re-implement most of this. So, read particles. So, we'll do fn, this will be a string. Um, and we will save this read load BGEO. Now the first thing it's going to do, kind of want to turn this off. It's going to read the magic from the file, make sure that it's right. It's going to read the version, and then we'll get some endpoint and whatnot. Now there are utilities we can use to read all of these different things. In particular, I've got a bunch that I've implemented and used in YT, but here we'll just use struct. Struct is a nice simple way to do this, although sometimes I forget the exact way to do this. So we'll do struct format, and here it's giving me stuff, but I actually don't want that. We'll do 5 characters, and now let's check that. Here, so let's do this. Read load BGEO, and let's try read particles. Home mturk cluster no bh. What was the name of the file? 18d.000.bgeo. Yeah, it didn't work. Oh, no bh6. Okay, so this gives us what we are hoping for here. It actually gives us BGEOV. So let's compare this to so we'll call that magic, and then I'm just going to do real here. That's actually V. Let's see what that does. And here I'm going to do all right, let's try that. Copy, paste. Well, that hung. Let's see, there we go. No, I don't know what's going on there. That was weird. Home mturk cluster, no bh6, 18d. Not a valid BGEO file. Oh yeah, these. There we go. Okay. Now let's read the rest here. Version, endpoints, and prims. So I'm going to copy all this. I'll put that up there, but we'll end up copying that all out. So I don't want that to be that. We'll just leave that. There we go. Okay, so now let's go back up here. We'll come up with a dictionary. BGEO header. We'll have this in a dictionary. We kind of, you know what? I know that they're sorted and all that, but for insertion, but I don't quite trust it. Man, it's taking all the fun stuff out because it's just doing it all for me. Huh, that's weird. Ooh, not good. My Home Assistant just broke everything. That's not great. that's irrelevant to what we're doing here. Okay, so let's make sure we got this right. N-prim groups. Version is an I, endpoints, n-prims, endpoint groups. N-prim groups, endpoint attrib, and vertex attrib. Endpoint attrib. Prim attrib and attrib, yeah, that looks right. Nope, don't need anything else. So now what we do, we'll call this magic. Okay, yep, we want that. Okay, now for, yeah, name dtype. Okay. All right, let's see what it looks like. Nope, those are wrong. So I think that's because these are all big endian, which is definitely, you know what? I can actually just do that right here. Calc size format. We will say format equals f big format. Yeah, there we go. Endpoints 30,010. Okay, so this is getting us a little bit closer. So now we've got endpoint attrib. All right, we're getting there. Now let's read a particle attribute. Okay, so we'll get a particle attribute, attribute header, name length. Okay, that'll be, you know what, I'm just going to write a special purpose one for that. Read attribute header f. That's, I think, supposed to be ASCII. Read struct format. It's not dtype. Attribute size, attribute type. So that'll be size first, then we'll come up with our enum there. Now we have to read our default values. So we will f.read 4 times size. Skip default values. Okay. Yeah, dtype map. Dtype map equals that. Now we only have a couple different attribute types. 0 maps to float 32. 1 to int. 2 to string, but I don't want to support that. We'll do 3 to float 32, but we are going to have to eventually fix that because that's a vector. So we'll do something that'll break, and we'll call it that. Okay, so now let's read our headers. For I in range, oh, and we got to do our header name equals value equals that. This will be header name. Okay, we'll call that for I in range header and trib. name dtype equals read attribute header. I don't want any of this. I want this. Print attribute, but now we got to get rid of all this crap. Okay, so let's see what that looks like. Tuple object cannot be. Oh yeah. So here we'll do header name, comma, because these are all single. Okay. Oh, it's point attrib in this case. That's interesting. What exactly is that? I don't remember seeing that inside my KSV, so let's take a look real quick. E. It's not. E6. Okay, where am I getting an E6? I'm seeing a bunch of 6Es, but I'm not seeing any E6s here. E6 is right there, so that must be overreading somehow. Is it reading too many? Looks like it happens in the very first go. Oh, because this is not an I. That, the name length is not, yeah, it's short, so that's capital I. Isn't it? H. Now it's got a D3. Attribute size is also an H. Okay. So it grabbed all of those. Great. Now we just create a new NumPy dtype. So now, new dtype equals. That's not correct. I mean, it will be in this particular case, but it's not going to be correct in general. So this will be largely correct, but yeah, we'll do that. Okay, and now we add to that name dtype for name dtype in. And then actually what we'll do here is we'll do attributes dot append yeah, I should be error checking on this. So new dtype is equal to that. This doesn't even need to be that. It just needs to be plus attributes. Okay. Dtype equals new dtype. Okay, let's call this. Yep, that's wrong. Let's take a look. It is the right size. Let me put in an f.tel here. Okay, file position. Okay, and now let's ls that so we can see if I got to the right spot. Yeah, it's got some characters at the very end that are not showing up here, so. Okay. So, let's see. I think part of the problem here is all of these are supposed to be big endian. There's probably a way to byte swap numpy. Yeah, here. Why don't we just do this? Dot byte swap. Yeah, that looks right. In fact, I know that that's correct. So now we have all of our attributes in there. And the way that these are currently stored, if we wanted to do this inside Blender, what we would do is we would take a look over at, let's see, we can use Halo Importer as a sort of a basis here. Why is this open? Let me put that here so we can see it. Read load BGEO. What we'll do is make a new file, new Python file. We will call this import BGEO orbits. Import read load BGEO is RLB, sure. Import bpy, import data bpy. So what we'll do is we're going to first load all of these arrays in. And what we have to do is stack them and change them from the index, the way that it's set up currently, to... Oh, did my camera freeze at some point? Looks like it did. Here, let me try. No. Huh. Let's see, I forget how I fixed this before. Did that do it? No. There we go. All right. It'll probably do that again. So we're going to load our import BGEO objects. And what we'll do is we'll say cluster path. I don't want it in temp. Now, we don't want this to include orbits. There we go. All right. So we've got all those. So let's come up with our stack. For fn in fn's, rlb.read bg read particles fn. So now, all right. So let's see. These were all the same size. Right now they're all 1D, so let's do that. And now arrays equals np.array arrays. Now let's take a look at what this gives us. I'm going to comment that out so that we can actually just run it. We'll call this import BGEO orbits, import OS, import glob, import numpy as np. Oh, it's printing them all out, of course, but I don't want that. So I'll have to go ahead and kill that. Okay, looks like it's ready to go. Takes a while, of course. And it is loading a fair bit into memory, and it has to read them all. And then I've got this append operation. Oh man, yeah, of course it's going to take a while. Okay. So, let's take a look at what ours looks like. So we've got 1,600 time steps. That gives us particle 0 for each one. Awesome. So, for the only thing that I really want right now, you know what? Let's just go berserk with this. For I in range 100. Positions equals ours. Yeah, sure. There we go. I colon. Yeah, it's 2 dimensions. So what we need to do here is actually can I do multiple? Nope. Okay. So now let's create an object. New objects.append object. Okay. Yeah, we want to do that afterwards. So object equals data bpy. Yeah, that looks right. All right, now let's go back on over to Blender. Getting close now. Geometry node, no, scripting. Oops. Oops. No module named read load BGEO. Right. It's got something funny with its Python path. os.path.insert. We'll say tilde yt blend yt. Reload from disk. No module named read load BGEO. Huh, I wonder why not. well, okay. Maybe that'll work. Nope, invalid syntax, of course. Okay, here's what we'll do. We'll just put it all in here. Okay, we'll just put it all in there. I know it's not amazing, but so now we'll open. Oh, and that crashed. That was fun. Wonder why I did that. All right, well, let's take a look at it with the debug log on. Oh, it runs the if name equals main. All right. If 0, and there we go. I'll just comment that out. RLB is not defined, of course. Now it's all in the same file. So we should now have a whole bunch of new objects here with all their positions and everything. Should be about 100 of them. It'll happen after it finishes loading them all in, which remember took a bit. Oh, that's interesting. Oh, right, because it's loading them all in as vertices, right? Actually, that does not really look right, does it? Am I doing... Ha! Yeah, that's fun. So part of the reason that it was failing was because I used the AI suggested code that had everything in the reverse order. It wasn't even that it was failing, it was just giving wrong results. Okay. Yeah, there we go. Okay, so these are the first 100 particles. So let's see. Let's come up with a quick little geometry node. Oh wow, particle 0 is right there on the axis. Okay. We want to take these are vertices, so mesh to points. Can I do mesh to curve? I can, right there. No, that's not the one we want. Okay. Mesh to points. Now we've got points, points to curves. There we go. Okay, now this we will call vertices to curve. And we actually want to do this to all of them. Nope, it doesn't apply to all of them. So I guess that's, well, you know what? We'll come back to this because I think we actually can join all of these. Yeah. Now they all seem to include that, which I don't totally understand, but we'll figure that out later on. So now the curve outputs here. That's way too many. That's 16,000. So they're each coming back on it. Okay. Well, let's go back. We'll do it just to a couple of them. Let me delete this. And we've got this now. Let's delete our cube. Let's reload and rerun. Still doing it. There we go. So let's take this and we will now, how do we disable, I just want to hide these. There we go. So now we've just got this one. What is that one? Oh, for some reason that one was also enabled. So we've got this. All right, we'll add a modifier. Geometry nodes, we'll use the one we came up with before. And so now we've got 1600 frames here. Okay. So what we can end up doing here is we can create a new object. Let's just go on into geometry nodes. We'll add a new UV sphere. Give it new geometry nodes. We'll do sphere follow path. And actually, I'm going to go ahead and get rid of that because I like to control it all in here. UV sphere. Okay. So we will do curve, sample curve. And ultimately, it would be nice if all these were joined as a single curve index, or single curve. So, oh, you know what? we'll come up with instances in a minute. Okay. Let's get rid of that. So we've got a collection info. And let's put all of our particles inside a new collection. And let's get rid of this. So let's get rid of we'll just leave them as they are. Now let's look at our sphere. We'll take our collection info. Each one of these instances, we will have a new geometry node, collection 2. Okay. Now vertices to curve. I don't know if I need to do this for each one, but maybe we do. This looks like it's got one instance coming out. So that's, I don't know if that's what we want either. So instances, I am just going to, I'm sure there's a way to do this. We'll do for each element instance. And then element goes there. And then this is the original input. This is our joined geometry. So now what is our output here? One instance of collection 2. Where this has one spline with all the different curve points. Okay, so I think that does it. Now I'm still confused what's up with those. But it looks like it's not the same as it was before. So I think this is giving us the correct number of output curves. One curve with a set of 1600 control points for each one. Okay. So now for each one of those, and you know, I gotta think there's a way to do this that doesn't involve the for each element, but I guess we're okay. So now for each element, we're going to sample this curve. Geometry goes into, nope, the joined geometry goes in there. Our curve index is eventually going to be our, we're going to create points. This goes into domain size in order to figure out the number of instances. And then here we'll just do, oh, there's no group output. Okay, we'll just output those. There's one. No, I don't want to do that. Let's see. Link that to viewer. Yeah, there's 100 instances. So why is that? You know what? We'll just do this. Instances 1. There's one instance here? Okay, that should do it. Instances. Yeah, all right, so now we've got 100 instances, and I think that actually probably fixed some issues here that I wasn't quite picking up on. Yeah, I think it does. So we've got our points. So now what we need to do is we need to instance on those points. Let's get rid of this. So we'll sample these curves. We will sample instance index. Oh, looks like I'm done with the new garbage album already. Huh. Well, I've got another 20 minutes or so. Why don't I listen to this? Okay, we'll listen to some Foo Fighters. So now we've got this many points. We're going to sample along that curve index for each one. And then that's going to go into our positions. Instances in input geometry are ignored. 100 points. That's a vector. Well, let's realize our instances. There we go. Okay, so now we've got this instance on points, instance our mesh. Okay, and now let's change our radius. And so now, if I change my sample factor to frame divided by 250, I get all my spheres moving in sequence along the full time step. So this is big. I like this. You see it starts over. Let's make this a little bit smaller. 1 in 10. Okay, so what would be nice, and I think we can do this, let's join our geometries. Yeah, okay. Now let's take our curves. We will trim our curves. Okay. And then end will be at frame divided by 250. Okay, so now we've got our curves. We're letting it draw them out. We're seeing this whole hive of activity. They're drawing it out. Now this is one thing I just want to note is I've done this in D3 as well, and in D3, it's 2D in the cases that I did it, but it requires setting like a pen that draws progressively, and you change the start position and stuff, and it's all idiomatic, but it's also not. I mean, this is a little bit more intuitive. Maybe there's a better way to do it in D3 than what I found, but okay. Now we've got our curve. One thing we could do, let's see. There's a way to... Oh, really? Oh, thanks. Let me try to adjust that. Okay. Oh yeah, my microphone was pretty low. Oh gosh, you know what? I don't think it's even recording from my... How about now? Is this any better? Is that any better? I can't even tell. My, let's see. Mic aux. Which one is it set to? Yeah, it's set to the right one. But, yeah. Okay. Hopefully this will be a little bit louder, more audible. I'm really hoping that fixes it. Still low. Oh, man. All right, let's try... input devices, recording. What if I up it like right here? I'm now amplifying it by like 40%. Might still be pretty low. It says that it's going all the way up into the... Okay, better. Great. Thank you. Sorry about that. Oh boy. It's just going to be me mumbling to myself in this. All right. I did say 40%. That's right. All right. Now let's see. We've got our curve, sample curve. What I want to do now is I'm going to take my geometry and I am going to... I'm going to take my curve. What we'll do is we will do a curve to mesh on this. Our profile curve in this case is going to be a curve circle. That's going to be my profile here. And so now what you see is all of these, it'll be drawing these gigantic tubes everywhere. So let's go ahead and drop our radius here. And we will we want this, we will only have it go the last 0.25 or so. So now these objects let's see. Yeah, wormholes. Yeah, it does kind of look like wormholes. So what I've got now is in this new one here, and I'm going to make it so that it just does the last 10%. Now you can see the trails receding behind them. What I'll do is for our set curve radius here, we will have our curve radius. And then here we'll set that back to 1. We'll set our radius. For some reason I thought that would impact it, but I guess it doesn't. Alright, so let's get rid of that. And instead, our scale. Does that take a vector? No. We really do want our curve radius to be... we want our curve radius... Yeah, alright, that'll change the radius as we go, but I don't really want that. Let's delete that driver. Now, I thought that I could change my curve radius based on curve parameter, spline parameter. So let's take that. Let's see if it'll change it with distance. Nope, it won't. But we are at least getting this curve sort of moving along with us. I was really hoping to be able to get a tapered value there. But I'm not getting a tapered value. So I guess we'll have to do something with that, but yeah, we don't want that. We want this one. So we've got our orbits all going. I've loaded them in from BGO files, truncated them. Really, I wanted the parameter there so that I could have some degree of, yeah, it does kind of look like the FSM. I wanted to have the parameter so that we could change the width, but having the profile curve, oh, that's the problem. Set curve radius. This is where that goes. Okay, so now when I change the radius, and now curve circle. Okay, so now we've got that. Huh. I thought for sure that would do it, but it looks like it's not. Okay. Yeah, so I was under the impression, you know what, and maybe the problem here is that the curve to mesh is coming at it from the wrong perspective. I was under the impression that I could change my curve radius along the path and that would change my mesh profile size, but that's not what seems to be happening. So I'm wondering if I'm misunderstanding this somehow. And I mean, I probably am. Okay, I'm going to untrim my curve. And let's do set curve radius. Now, in theory, I thought that would update the radius of my extruded mesh, or not extruded, but of my followed mesh, but it seems like it's not. So let me go back. I'm going to undo the last couple things. Hear about the hand you've been dealt. I want to go back to where I was a minute ago. Missing some frames because of rendering lag, but that's to be expected. All these times I've moved it. There we go. That's what I wanted. Okay, so now I've got this selection, true. Yeah, so it's doing it. If I do wireframe, maybe I'll be able to see it better. Oh wow, wireframe's also hurting it. Let me drop this. I actually don't need that high of resolution on the circles. Yeah. So that dropped it by a fair bit, number of vertices. Let's view my... You know what? Maybe we should do that in here. This realizes my instances. What if I do this? Nope. Yeah, what I would really like, scale the profile at each point. Maybe that's where it should be. Spline control point, spline parameter. There we go. Oh, that's exactly what I was looking for. Okay, so now what we've got is we've got all these little tadpoles flying around. Now, I think that toward the very end, where the parameter is equal to 0, it's going to be, and I think it is reset to the correct times. It's a curved circle, radius 0.1, UV sphere, radius 0.05. So let's do this. Now the spheres should be just inside. Awesome. Okay, this is exactly what I was looking for. So they almost join. Now, of course, they don't precisely because of the way that they're oriented. So let's do read curve tilt. No, tangent, curve tangent. So now let's input this to rotation. That did not do it. Oh, probably because, yeah, the tangent's not going to do it. So let's see. What I really want to do is I want to have these spheres aligned along the axis. Curve tilt. Oh, but I'm not catching it right there. So, yeah, because each sphere is not able to access the field parameters off that. So maybe what I need to do is, we've got instance this on our points. Somehow here we have to be able to translate we have to be able to get these attributes over here. But right now they're not. Maybe instead capture attribute. Yeah, well, there's a way to do this, but I'm pretty happy with where I got for now. Let me go ahead and push this up. Yeah. Awesome. Okay, well, it's time for me to go to my next meeting, but I am reasonably pleased with where this got. Got some cool little tadpole-y orbits going. Yeah. Thanks for joining, Cryogi, and sorry I had a low mic for so long. All right. Catch you later.